Hey guys, so a few weeks back I was traveling to Tanzania and they speak Swahili there, and I have no idea of Swahili. So I was trying to figure out what are the common phrases that you can use, like hello, how are you, where is the restroom, kind of things. And I quickly figured out that that wasn't gonna work. That's not the way my brain works. So I tried to hack it. So what I did is I found out a corpus of Swahili, spoken Swahili, and then I figured out the most common words and I tried to learn that, and it kind of worked well. So I wanted to show you how that works. I'm going to do it with the Spanish, since the Spanish is my native language, and I can provide some context on the words themselves. Um, let's just get started. Um, for Spanish, you should just look for Spanish corpus. And here I want to give a caveat. The most important things is what language you want to speak, and because it's very different, the spoken language from the written language. So you could use here, for example, this data set from Kaggle. This is 120 million word in Spanish corpus. Um, if you download it, which I already did here, have it here, you can start looking into it. So let's look at it. So the file is there. It's 120 million words. We can unzip it. 120 million words, and that's going to have a bunch of files inside. Each one of these files contains a number of documents inside. Okay, so let's look at one of these files. Head, Spanish corpus, Spanish text, and it seems to be some kind of XML document, and then the context, acontecimientos and nacimientos, fallecimientos. This sounds like a newspaper with like news of the day, or like happenings, births and deaths. If we take other document, for example this one, it looks very different. It looks like like some document inside the a website related to a university. And we can try with a few more of those, and this one looks completely different. So depending which one of these files you pick, the language is going to be slightly different. The kind of words and the way people speak is going to be completely different. Another thing you notice is that you have these signs here, which means that the language wasn't properly matched, so we can deal with that. Also, this doc is because in XML, so that leads me to think that at the end there's also a doc, which is basically the closing. Now the question is whether there are more of those or not. So we can find that by just grabbing that doc in Spanish corpus, Spanish text, any of those, and you see that there's a bunch of docs. So what we'll expect is inside this doc, each one of these files, there is a number of small documents coming from different places, and the description of the document is included here in the opening tag with some ID, and I bet you can just use that for figuring out where did that come from. We can see how many of those are there, about 4,000, so I think that has to do with this number in here, but that's not relevant for what we're trying to do. So let's see. If we have a Spanish corpus here, actually it's better if we do this. Span.grep Spanish text. Then we have the name of the file here. I'm going to put this in a variable called files. And then I'm going to call file just the first one of those, so F, actually, file 0, right? Once we have this, we can do just open the file, read it, and then let's see the first 1,000 characters. Immediately we get this Unicode error. That happens because the language that was used to write the file, the encoding that was used to write the file, is not the same encoding that was used to open the file. In this case, I found that for Spanish, a good encoding is the ISO 8859-1, and then there you have it. You can see that the file was correctly opened. The accents are in the proper places. There are no weird things. So that's great. So let's put this together, and let's just call this read file, right? And then we can put this here. We read it dot split lines. We actually can just return it like this. Then return. Awesome. Now, actually, it's easier if we create a memory. Read split lines. So we can do some quick checks. So let's do read file. Let's get the first 10 lines. Oh, you gotta read the file. The first 10 lines looks like expected. The last 10 lines. Yeah, we have these empty lines and this end of article. Nice. So the next step would be to filter those. Let's call it read lines actually, because it's going to be returning as lines already. The next step will be to filter some of these lines. So let's write filter lines, and this receives a line string. And then for line in lines, if line dot starts with doc, continue. That's gonna filter, like skip the line. If line dot starts with closing doc, continue. And then yield line. So in this case, we can do something like lines equals read file. Then for line in filter lines, then print line. But this is going to print all the lines, and we don't want that, so let's cap this to 100 lines. And there you go, we have a few lines, and then empty stuff, and then end of article. No. So we should filter all this empty stuff. To do that, we just do the same here. Line equals line.strip. If not line, continue. There you go. We have acontecimientos, nacimientos, fallecimientos. So like I said, this file seems to be dealing with something related to news of borns and deaths. We can pick another file, and it looks completely different. It has to do with some website crawling, it looks like. And another file looks completely different. So let's take this one for now. What else can we filter? We should definitely filter this end of article. The easiest way is just to have it here. The line dot starts with end of article, end of article. Continue. This looks good already. Perfect. Now that we have the lines, we should take care of something, and is that now we don't care so much about the lines. We care much about the frequency of the words. So let's work on that. So we had filter lines. Now we should do def get words in line. Yeah, get words. So we pass a line and then for line in lines, for word in line, the word. So here we can do filtered lines equals filter lines, and then for word in get words, from filter lines, print line. Oh, yeah, this shouldn't be line, it should be word. There you go. And we didn't get the words. So that happened because we didn't split the words here. We just have to do line.split, and now we have words. But now we have the words like we will need them, but we should try to avoid these and we got the words. But notice now that we have a few issues still. We have punctuation signs, we have caps and lowercase in the same place. So we need to work with that. So let's work with that. So the first thing is to do let's try to work on a fixed filter words or fixed words. So line equals fixed text line, and then we can do def fixed text line. Oh, let's call it text. And then what we're gonna do is try to replace some words, so some characters. So to replace, for example, comma, dot, exclamation point, open and closing parent, the numbers, colon, semicolon, things like that. And then for C into replace, text is equal to text.replace C and space, and then return text. Nice, we have all the words now. Now the next step is to fix the case. That's super simple. We just add here, convert it into lower, and then you have it. Oh, there's a dash, so a dash here. This doesn't have to be super perfect because at the end of the day, since we're gonna do statistics over a large corpus, then things are gonna get filtered by frequency. Less common things won't really matter. So you don't have to be super precise here, but doing some cleaning always helps. Nice, so we have all the words already prepared, and the next step is simple. We just do a counter. Call these words, and then we do something like import collections, counter equals collections dot counter, and we pass the words in there. Get words here, and then we can ask the counter how many words were there, and then counter in this specific test there were only 322 words. Out of that, counter dot most common 10 are articles, de, la, el, en, and adverbs, like con and a, which is what is expected in a language that has adverbs. Let's try to make this slightly better. So you can do def all words, and then what we do is for, let's get the files again here. For file in files, let's call it def, and then we just do this lines equal red file, filter lines words, perfect, and yield word. Now in this case we have 57 files, so it's going to take a little bit of a time, but let's see if this works as expected. First load this, and let's add a time to see how long it takes, and we just say all words. Okay, so here we have, it took about 9 seconds, then let counter up. This doesn't make sense. Oh, I see what happens. Yeah, here I'm yielding just one word all the time. So let's actually yield from words. Okay, that's better. Seven seconds. Yeah, this makes more sense. So let's see, len counter. There are a total of 11,000 words. That's because we are using this. Okay, let's do it again. Sorry, every single time there is an error. So let's load it again. It's gonna take a little bit longer this time. Okay, it took a full minute and a half. My computer hard disk drive is kind of slow, so that's why it will take so long. But that just shows you that even reading all these words in a modest computer is not that bad of a deal. Yeah, in this case we have 1,300,000 words that are different, and we can see the most common. Counter.most common. For example, 10. Like I mentioned before, it probably will be just articles and adverbs, but we can get a little bit more information if let's save this into a variable most common equals counter most common. Let's get them all so we can see what's going on. Okay, so the first thing, like I mentioned, was the most common ones. Let's see the first 100. After you pass the adverbs, you start talking about other words like pero, sobre, no, those are adverbs, hasta, ciudad, and then you start looking at actually words that are written like historia, primera, primer, fueron, siglo, mismo, España, and then if we look at the last 100, you find words that are not Spanish, or that are like they have tildes, or they have clear mistakes, question mark. Okay, so if I were to repeat this, I will just try to remove question mark from here. Things like this, percentage, $sign. But I think the first 1,000 is what we're caring about. Perfect. So you can find useful words like está, después, nombre, historia. Remember that this corpus is a written corpus. So another important corpus will be a spoken corpus, Spanish spoken corpus. And I found this this one right here, collect, which has a large file. And you can download it right here. If you download it, you can also take a look at it right here. Let's see, photo. Creates a bunch of files, but these ones are the interesting ones. And it tells you that it's a file recorded between two men of 50 years, and it tells you how like people speak. So this shows you a couple of ways of getting data sets, and the important thing here is that if you want to read newspapers, for example, this is a very useful data set. If you want to learn how to speak with people, this is a more useful data set. But okay, let's continue with this most common. Most common. Let's get the first 200, right? This first 200 tells us what's the word and what is the frequency. So you can do something like Scilab inline and then plot j for I, comma j in most common 200. And that shows you how the frequency drops rapidly after the first 10. If we chop, because those are the articles that are used before every noun, we can get a little bit better of the information after the first 20. So here you see something very interesting, like even for the first 175, the difference in frequency is tremendous. Like you get all the articles and adverbs of position, and after a few, like dozens, like I would say 50, you have these are more common words that you would like to learn. So if I was going to learn Spanish and I wanted to learn some useful language to learn, to be able to read a newspaper, I will learn basically the first 200 words. So if you have these 200 words and you learn 50 words a day, it will take you 4 days, just the better part of a week to learn these 200 words, and that's not too bad actually. If you want to get more understanding, obviously 500 words will give you better understanding, and it will take you, if you repeat every word, it's going to take you about 3 weeks to a month. And that's crazy because you can learn 500 words in a month and be able to speak a lot of the functional Spanish to read a newspaper. To be able to give you better information of how much do you get by learning 500 words, you can just do very quickly pandas.data frame. Then we can get the most common, and then columns equal word and frequency, and this is a split. And then the data frame looks like this now, which is what you expect. This data frame you can take and do things like frequency.plot, which is not very useful because it's a sharp drop for the first few words and nothing else really matters. It's more interesting if you look at the first 1,000 words, which still tells you that these words are the most popular ones. The first 100 words give you most of the bang for the buck, but the rest are also useful. So you can keep on doing things like, for example, the console plot. and this is actually even more interesting. Like to reach 100% of understanding means if you know every single one of these words, you can read pretty much 100% of the text, right? But what is more interesting is to do something like limit this to the first 1,000 words. And what this tells you is that if you learn the first 1,000 words, you're already in 60% of understanding. So why would you try to learn 1,000,000 words if you can do 60% with 1,000 words? And you can even go a little bit further with 2,000 words, and that will get you to 75%, or 70%, which is already like like 3 words out of 4. This is enough for understand. So if you try to learn 1,000 or 2,000 words, let's call it 1,000, and you see each word 3 times, so you need to learn 3,000 words. And if you're learning 50 words a day, it's only going to take you 60 days, 2 months to learn 1,000 words. That gives you past half of all the Spanish, the written Spanish. So this is a very powerful technique to focus in on the words that you actually need to learn, and I think it's a very valuable view of the data. As a student exercise, I recommend you go through the same exercise, but this time using this other data set, and figure out the results. I bet written Spanish, and in general any written language, is more uses more language than spoken language. So the results with the spoken Spanish are going to be even more astonishing. Probably 1,000 words are going to be enough to understanding 70 or 80% of all the language. So I think that's a very valuable lesson. If you have any questions, just please comment below and like and subscribe. Thank you.